Hello viewers, in this video I would like to discuss interpolation, approximation and Lagrange's interpolation formula. What is an interpolation? Basically, if we have n number of points, say x, y, y is a function of x. So if we want to find out value of y at a particular value of x which lies between this set of data which is given to us, then we call it interpolation. So we are finding value of y at a particular value of x which is not available in the given data. So interpolation is a technique of estimating the value of a function for any intermediate values of independent variable x. So value of function means y or fx given a table of discrete data points xi, fi. It means we have x as independent variable, y or fx is dependent variable, and we are trying to find out value of function f at a particular value of x which is lying between these data points. So what is use of interpolation? Reconstructing the function fx. So either we can directly find the value of f, or we can reconstruct the function fx in terms of x when it is not known explicitly and only the values of fx and or its certain derivatives at a set of points are known. So we can reconstruct the function and find out the value of fx by putting the value of x in that function. Replace the function fx by an interpolating polynomial px so that operations such as determination of roots, differentiation and integration for the function fx may be performed using px. So all these things we need to find out when we don't have exact solution, exact differentiation or integration. So we can use this numerical technique for doing that. Now interpolating polynomial, let's have xi, fi points. I takes value 0, 1 up to n be a given set of n plus 1 points. 0, 1, 2, 3 and so on up to n means n plus 1 points, where xi are all distinct. Then the polynomial px of degree less than equal to n is said to be interpolating polynomial if pxi is equal to fi. I takes values 0, 1 up to n. Why do we need interpolating polynomial? Basically we can find out or interpolate value of y for a particular value of x with the help of formula, but sometimes we need to have interpolating polynomial in terms of x. So for any particular value of x we can find out value of y with the help of polynomial. So Lagrange interpolating polynomial. The Lagrange interpolating polynomial exhibit the existence of polynomial for interpolation with unevenly spaced data. So we can have two types of data. Evenly spaced means difference between two consecutive values of x is same, and unevenly spaced data when difference between two consecutive values of x is different. So Lagrange interpolating polynomial, and we apply Newton's divided interpolating polynomial also, but here we are talking about Lagrange interpolating polynomial only. So we are taking values of y or f in terms of f0, f1 up to fn. Corresponding values are x0, x1 up to xn, and these are distinct point, and we say that polynomial can be depicted by pxi is equal to fi, and this is the function which takes n plus 1 values. So px can be represented as polynomial of nth degree in x. So let this polynomial be of the form, we take any form which we are writing here, and this form we will be finally finding out the exact form of this. So it is px is equal to a0 x minus x1 into x minus x2 up to x minus xn plus a1 x minus x0 x minus x2. See here x1 is not there, In the previous term, x minus x0 was not there, up to x minus xn plus an. Here x minus x0, x minus x1 up to x minus xn minus 1. Here x minus xn is not there. Now we put x is equal to x0 in px. So our first term is here, all other terms becomes 0 because all other terms have x minus x0 term, that becomes 0, so they become 0. So finally px0 is equal to f0, which is equal to the first term of the polynomial, which is a0, x0 minus x1, x0 minus x2 up to x0 minus xn. Now we find out a0 from here. a0 is equal to f0 upon this one. Now we calculate x is equal to x1 in the polynomial. We put this value and find out value of a1. So we got a1 this. Similarly, we can put x is equal to x2 and we can find out value of a2. And finally we put x is equal to xn and find out value of an. All these values we can, substituting the values of a0, a1, an in the px, which is the polynomial we had assumed, we get the Lagrange interpolation formula, and this is the interpolation formula. Now we can write down it in a short form, where we can take coefficient of f0 as L0x and coefficient of f1 is L1x, coefficient of fn is lnx. So we have written it in short form, and further in summation form, I is equal to 0 to n lix fi, where lix is this the product. So and lixij is equal to 1 for I is equal to j and 0 for I is not equal to j. This formula can be used irrespective of whether the value x0, x1, xn are equally spaced or not, and formula is this same formula. The Lagrange polynomial passes through each of the points used in construction. For example, substitute x is equal to x1 in the Lagrange polynomial. All terms except the. Now let's so we have to calculate the value in terms of x. So if we simplify it, we will have a polynomial in x. It can be further simplified, and in the question we have to find out value of e to the power 1.5. So we put 1.5 in the above polynomial, that is x is equal to 1.5, and get this value 4.4301. Thank you.